Hello and welcome to my channel. In this video we are going to solve a question from Circle Theorems topic. A, B, C and D are points on the circumference of the circle. DE is a tangent to the circle at point D. BC is parallel to the line DE and angle CDE is equal to 61 degrees. Work out the size of angle BAC and write down any circle theorems that you use. So let us try to understand the question first. Here it has been given that the points A, B, C and D lie on the circumference of the circle and DE is a tangent to the circle at point D. So tangent is a line which just touches the circle at one point. So this tangent DE is touching this circle at just one point, which is point D. The next piece of information given is this tangent DE is parallel to the line BC. So we can see the arrows being given. And the last information given is angle CDE is equal to 61 degrees. So in this question we have to find out the measure of the angle BAC, which is this angle. So let me reconsider this figure again for easy reference. Now in this figure, angle BCD will be equal to angle CDE because these two are the alternating angles of the parallel lines BC and DE. So here we have written angle CDE is equal to angle BCD is equal to 61 degrees. That is the alternating angles of parallel lines BC and DE. Now once we have got this angle, let us make a small construction. That is, we are going to join the points B and D. Now once we join these 2 points, we have to make use of a circle theorem, which is alternate segment theorem. It states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So let us try to understand this statement. According to the statement, the angle that lies between a tangent and a chord. So in this circle, we have a tangent ABC that connects the circle at point B, and to this tangent, 2 chords are connected, that is BD and BE. So in this case, let us consider that this chord BD divides the entire circle into 2 segments. One is the small segment called as the minor segment, and one is the larger segment called as the major segment. Now let us focus on the statement given. It states that the angle that lies between the chord and the tangent. So here let us say that this is the angle made between the chord BD and the tangent AC, and let us say that this is going to be, for example, 30 degrees. So this is the angle made between the chord and the tangent. So this angle is going to be equal to the angle made by the same chord but in the alternate segment. Now this 30-degree angle is made in the minor segment by the chord BD. So this angle is going to be equal to the angle made by the same chord. So we can see that the point B and D make an angle in the major segment or in the alternate segment. So this angle is also going to be 30 degrees. So this is our alternate segment theorem. So let us see how we can use this theorem to solve the example above. Now here DE was given as the tangent, and we can see that CD is a chord that makes an angle of 61 degrees with the tangent. So the same chord is making an angle in the major segment at point B. So these are the 2 points through which we are going to make an angle at point B. So this angle is also going to be 61 degrees. That is by using the alternate segment theorem. So here we have written angle CDE is equal to angle CBD is equal to 61 degrees. That is by using alternate segment theorem. Now let us focus on the triangle BCD. So here we have highlighted the triangle. So consider triangle BCD. So now by using the angle sum property of a triangle, we can write angle B plus angle C plus angle D should be equal to 180 degrees. Now we have the values of angle B and angle C with us. So here we have substituted their values. That is, angle B is 61 degrees plus angle C is 61 degrees plus angle D is equal to 180 degrees. Now taking these 2 angles on the right hand side, we get angle D is equal to 180 degrees minus 61 and minus 61. So here we have the value of angle D, that is angle CDB as 58 degrees. Now once we have got this angle, let us focus on finding the angle BAC, that is this angle. And to find out this angle, we are going to make use of another circle theorem, which is angles in the same segment theorem. It states that the angles in the same segment are equal. So here you can see we have drawn a circle and we have considered 2 points A and B. These 2 points divide the entire circle into 2 segments. One is this smaller segment called as the minor segment, and one is this larger segment called as the major segment. Now using these 2 points, you can see that we have drawn multiple angles in the major segment, that is at point C, point D and point E. You can draw n number of angles over here. So here, for example, if we consider the angle ACB to as 10 degrees, then angle D is also going to be 10 degrees and angle E is also going to be 10 degrees. So this is the angles in the same segment theorem. So let us see how we can use this theorem to solve the example above. Now here I have considered the same figure for easy reference. Now let us consider the 2 points B and C on the circumference of the circle. So these 2 points will divide the entire circle into 2 segments. One is the small segment, that is the minor segment, and this is the larger segment, which is the major segment. So now we can see that these 2 points make an angle at point A in the major segment this way, and they also make an angle at point D in the major segment this way. So by using the angles in the same segment theorem, now we can say that the value of the angle BAC is going to be 58 degrees. So here we have written angle BAC is equal to angle BDC is equal to 58 degrees. That is by using angles in the same segment theorem. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.